All right. Two dash two. 2-2. We are going to intro to matrices. You're going to find out. Intro to matrices. No, this is not the matrix, but this is a matrice. Where would you see a matrix? Let me talk about this. We have got a farmer, and that farmer produces corn, soybeans, and wheat. All right? And what they do is they have... Don't talk like that. Don't talk like that. What did you say? Crap or crop? Oh, it sounded like crap. Crap. I was like, well, I heard it. It sounded like crap. I was like, don't talk like that. I know I did. All right. This got me in trouble? Why? Yeah, I thought you said it. Well, I'm talking to you now, so I thought you said it. That's what it sounded like. Not crop. It sounded like crap. And I was like, don't talk like that. No, I'm leaving this on. This is my proof. All right. Sometimes. All right. Let's talk about this. So we got a farmer. And this farmer, through, let's say, July, August, and September, all right, produces, we'll call it corn, wheat, and we'll say beans. All right. Now, in July, I'm just going to throw something out there. It produces, let's say, 5,000 pounds of corn. All right. In August, they produce, let's say, 12,000 pounds of corn. And in September, they're able to get 21,000 pounds of corn. All right. In wheat, let's say in July, they produce 2,000 pounds of wheat. In August, they produce 5,000 pounds of wheat. But in September, it drops back to 3,000 pounds of wheat. We're creating a matrice here. Okay, this is something where we can create matrices. Beans, let's just throw out 1,000, 2,000, 3,000, okay? So we've created a matrice. And we're going to be able to work off these matrices. I'm going to show you how you add matrices, how you subtract matrices, how you multiply matrices. All right, that is going to be the three things off of this section. Matrices, none of you have seen before, correct? No. This is new. All right, so that's an example of where a matrice will come from when farmers may be doing something where they're keeping track of where their crops are at, okay? So let's take a look. If I have a matrix, I'm going to just do a 2 by 2. I'm going to say 2, 4, 7, and 5. Okay? I have a matrix. All right? Each individual, this is called a 2 by 2 matrix. And you can make your matrices as big as you want. I mean, they can go up to n number by m. And the way they typically look at it is it's n by m matrix. Or is it m by n? One of the two. I think it's m by m matrix. And they can get as big as they want to, as you want to get them. But being able to work with them, it's going to start off pretty basic, all right? But it's going to get into, when you get into the multiplication, it's going to get a little bit tougher. And that's good. Just giving you up front. When we start adding and subtracting them, it's easy. But when we multiply them, it gets tougher. Yeah, wait. All right. If I was to, pretty basic. If I have two matrices and I want to add them, let's go 3, 7, 9, 2. All right. We can have the same numbers in all of them too. It doesn't have to be that I have different numbers in each part of the matrix. This is pretty basic. Whatever is in this quadrant of the matrix, we add to that quadrant. The same quadrant, same quadrant. 2 plus 3 is 5. 4 plus 7 is 7 plus 9 is, and 5 plus 2 is, and that's what we'd add the matrices up to be. The same happens in subtraction. If we're going to subtract, we would add and we would subtract the same quadrant out. Now, can you add matrices, a 2 by 2 to a 3 by 3? Yeah. Because if I extended this down and extended this out, what are the other values? All right. So you can add, yes. Okay. You can add the matrices together. All right. The problem is when you add them, they would come out with whatever the value of the, let's say, the 3 by 3 would be in that case. It doesn't have to be an even 2 by 2. You could have a 2 by 3 matrix. All right. Where you had 1, 2, 3, 4, 5, 6. All right. And if I added this to a 1, 2, 3, 4, all right, you would be adding to just the first two here and then carry the other two over. So you can add to them. And you can subtract this way also. All right. That's legal. All right. Adding, subtracting, pretty easy. You see what happens on there, Sarah? You see what happens when we add and subtract? Kaylee, you got it? Okay, good. Multiplication. The easy part of multiplication. If I have a matrix, let's do it 1, 2, 3, 4. And I just multiply 2 by this. This is pretty easy also. I am going to multiply 2 by each one of the quadrants in this matrix. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 8, or 4 is 8. That's pretty easy. Okay? That's where it's going to get difficult. All right? That's where we're going to throw a little wrench into what's going on. If we multiply this way, it's pretty easy to do if we multiply just by a number. All right? All right. Everybody got that? See what we're doing there, Maddie? What's that? I'm multiplying matrices. All I'm doing is multiplying 2 by it, so I would multiply the 2 by each one of these in this quad. Okay? See what we did? All right. Let's take a look now if we have 2 matrices. We'll start off simple. 1, 2, 3, 4 times another matrices, and we'll call this 3, 4, 5, and 6. All right. In this way, the common way of thinking and what you've seen so far would be just multiply the 1 times the 3 and carry it over. That's not what happens. You have to multiply the 1 times the 3 and the 1 times the 5 to come up with this. 1 times 3 plus 1 times 5. And that's this number up here. All right. So then down here, for this one down here, it's going to be this column, this row. Okay. 1 times 5. I'm sorry, 3 times 5 Time out. Well, I just want to make sure that I'm doing this right. No, I'm right. Mm-mm. Okay. So in this case here, it's going to be, we're going to multiply this row by this column right here. So in this case here, it's 3 times 3, and I think I got this wrong here. Well, hold on. I want to make, I'll tell you, this stuff goofs me up too. A, B1, yeah, I do have this wrong right here. No. All right. 1 times 3, 2 times 5 gives you this column, this row. Okay, so this would be 2 times 5. And you're going to add them up. So it's this one and this one gives you the top corner. Then this one and this one give you the bottom corner. All right? If you kind of look at what, this is tough. This row and this one, where is it in common? You're in common in this corner right up here. It's this row column, right? Where is it pointing to? It's pointing to this one. This is the row, this is the column, so it's pointing at this quadrant down here. Okay, the second one's going to be 3 times 3 plus, yeah, that's the bottom corner, plus 4 times 5. 3 times 3, 4 times 5. Yeah, I told you, this is tough. Now you go over to the next one, all right? Now you've got this column and this row right here, right? All right? So now we go 2 times 4 for up here, 2 times 4 plus 4. Let's see, no, we're doing this one here. See how it gets confusing here? Is it 2 times 4 or should I be doing, no, 2 times 3. This should be 3. Hold on. That should be 3. Well, yeah, well, now you know how I feel when I'm looking at this. What the hell went on there? Trust me, this is on homework. 2 times 3. 2 times 3 because we're going 2 times the 3 because we're going upper corner. And then 4 times 4. Or 4 times. Yeah. I know I'm getting it right. This is tough. And then the last one down here is this one here and this one here. So we're going across this way, down this way. So it's 3 times 4. We'll be doing this again, guys. Trust me. Plus 4 times 6. Okay, this is a 2 by 2. This is 2 by 2. Imagine when you're working with a 3 by 3. I'm going to also show you where you can multiply a 2 by 3 by a 3 by 2. I'll also show you that, yes. This makes the brain think. So, 3 plus 10 is 13. 6 plus 16 is 22. 9 plus 20 is 29. And 12 plus 24 is 36. That would be your answer to multiplying those matrices out. It is, isn't it? Why do you think I'm having a hard time with this? Well, it actually. Top of my head right now, I don't know. I'll just be perfectly honest. I'll be perfectly honest with you. Yeah, well, perfectly honest with you, I don't know. You will use it later on in the chapter here to solve equations. It makes you think. All right. Yeah, this could make you crazy real quick. Okay. So what it basically says here is your rows, I can multiply a 2 by 3, which means I have a row which is 1, 2, 3, 4, 5, 6. But this one over here would have to be a 3 by 2. So you would have 1, 2, 3, 4, 5, 6, because you're going to take this and multiply it by this. This, multiply it by this. Okay, this multiplied by that. All the way down. Yes. We're not going to worry about that right now. We're not going to do this one right now. But I'm just showing that you can multiply. This is what you need to multiply by. We will learn how to do 2 by 2s. Let's take another one. 2 by 2. 1, yep. 5, 2, 6 times. Let's do a practice one here. 3, 4, 2, 1. Let's see if we can do that. Let's see if we can do this. It's this row by this column gives you this number here. This row by this column gives you this number. Yep. Oh, I see what you mean. Okay. This row right here. All right. If we do that row by this column, okay, it would give you this number. Mm-hmm. Should I do an A, B, C, D, E? All right, I'm going to just do it like this. A, B, C, D times capital A, capital B, capital C, capital D. This one up here would be A plus B, C. This one down here would be C, A plus D, C. That's okay. I got her. Yeah, I'm good now. Then this one over here would be, oh, not that one. A B plus B D. This one here would be C B plus D D. Got her? All right. What'd you come up with numbers? 13, 18, 39, 40. Okay, hold on once. Let's write that out once. 18? 13? 13? Down 18? 39? 48. What did you come up with, Danielle? Did you come up with that? You didn't do it? Get it done. Write that. Because this is part of what you do. Torture. like I said, the adding and subtracting and that first part of multiplying is real easy. But this here, this gives you another level of frustration. And then 5 times 2 plus 5 times 2. All right. No. A what? For what? Yeah, I don't think that 39's right. Yep, 9. Yep. So this 39 ain't right here. It's just 9, right? Because look at what we're doing. This row times this column, right? So 1 times 4, 5 times 1. Uh-uh.
No, I'm serious. Look, the last problem we did is wrong, and because I followed the steps exactly how we did this one, and if that's wrong, then this one's wrong too. Then
let's see. This one here, 1 times 4, exactly. 2 times 6. Should be that one there. Why'd you put it in there wrong?
I didn't look at it.
I think you put it in there wrong.
Come here, mister.
Well, the next one is 14 and 48.
Yeah, because then we should go. This down here should be this row, this column. So it should be 2 times 8 plus 4 times 6, or 1 times 6. So this down here, yeah.
It should be 2 times 4 plus 6 times 1.
Yeah, it should be 8 plus.
Oh, I think I erased it. Is it 18 right? Was it? 2 times 3 is 6, 12, 18. And then this one is 2 times 4, 6 times 1, 8, 14.
Mr. G.
I'm going to erase this.
Mr. G.
Yes, sir.
That means that this last round was wrong.
If it was wrong, we're going to see it on the recording.
Just hang on.
Because I'll find out. Did ya?
I followed the same exact steps as the last problem. I put the same number. You will in here, Hoyer.
Yeah. All right. Should we do one more, or do you guys want an assignment? You want an assignment?
Yeah. I never thought I'd beg for an assignment.
Beg for Wait. Wait, let's see. Let's see. Page 68. Page 68. I want you to do, let's do 17, 18, and 22. 17, 18, 22. 17, 18, 22. And then I want you to do, let's see. I want you to do 29. I want you to do 33 and 34. 29, 33, and 34. 29, 33, and 34. Let's see if you can figure out how to do 2 by 2s times a 2 by 3. And then there's going to be a 2 by 3 by 3 by 2. Yeah, well, I lied. All right. There's what we got.